We will now talk about factoring polynomials. Factoring is a very important skill in algebra. It is used extensively throughout for simplifying rational expressions and for solving equations, for instance. So those are just two examples where factoring is used. And there are several methods for factoring. We're going to discuss four. Well, the first one being always applicable, and the other three depends on the circumstances. So the first one is uh, if they ask you to factor something, the first thing you need to do is factor out the GCF. So let's review that. So factoring out the GCF means pulling out the greatest common factor. But you have to look at all the terms and see what is common, what factor is common to all of them at the same time. And you're going to be looking at two things. You're going to be looking at the coefficients, and you're also going to be looking at the powers. For the coefficients, you're just going to think of a number that is a factor of all of them at the same time, and you're going to think of the biggest number that is a factor of all of them at the same time, and that's just going to be your GCF for the coefficients. And then you're going to look at all the powers, and then you're going to think of what is the highest power that you can pull out from all of them at the same time, and that typically is going to be just the smallest of the powers. That's what it is. Because I cannot pull out x. I cannot pull out 3x's when all I have is 2, right? I cannot pull out an x cubed from an x squared, or I cannot pull out an x to the fourth from an x squared. So it's always going to be pretty much the smallest power that you see. That's going to be the greatest power that you can factor out from all of the terms at the same time. Okay, so let's start by doing the very first one. So first, the coefficients. Always start with the coefficients. So looking at all the coefficients, we have to think of what is the biggest number that you can think of that is a factor of 8 and 4 and 10 as well. The biggest factor is a 2 because 4 does not work. 4 does not go into 10. It's not a factor of 10. So, but 2 goes into 8, into 4, and into 10. 2 goes into all of them. So 2 is going to be the GCF for that coefficient. So you're going to write 2. Then, as we said, the largest power that you can pull out from all of them is going to be just the x squared because that's the smallest one, which is the largest that you can pull out from all of them at the same time. Okay, so then you write 2x squared on the outside, and then you have to think here, what do I need to write so that if I were to distribute, I get back the original polynomial. So here, you see, if I have a 2, and I need to have something here that when I multiply them, I get 8, that means I need a 4. And then what power of x do I need here so that when I multiply, I get x to the 4? Well, you need an x squared. Then if I were to multiply these two terms, I would get 8x squared. Ax to the 4th. All right, and then you keep moving on to the next one. You put that minus that was there. And then think, okay, from the 4x squared, what do I need to write here so that when I multiply it by 2x squared, I get 4x cubed. So I need a 2, so because 2 times 2 is 4. And then I need 1x because x times x squared is going to give me the x cubed that was originally present. And lastly, what do I need to write here so that when I multiply it by 2x squared, I get 10x squared? Well, I only need a 5. 5 times 2x squared is 10x squared. And that's it. We just factored out the GCF, which were the instructions. So that's that. All right. Okay, now let's do another example. 3x to the 6 minus 9x squared plus 3x. Okay, first, start with the coefficients. Look at the coefficients. 3, 9, you can ignore the sign. 3, 9, and 3. 3, 9, and 3. The biggest number that goes into all of them at the same time is just 3. So that means for the coefficients, the GCF is 3. Now look at the powers. The exponents are 6, 2, and 1. The biggest power of x that I can pull out from all of them at the same time is just x. X to the 1, but we don't write the 1, just x. Which, as I said, turns out to be the smallest power of the 3. Alright, so that's a GCF that goes outside. And now we think, what am I supposed to put here so that when I multiply by 3x, I get back 3x to the 6? Well, if you think about it, what you need is x to the 5. Because x to the 5 times 3x is 3x to the 6. Alright, then, alright, now moving on to the next one. Minus, that minus, you write that minus. And then, what do I need to get a 9? Well, I already have a 3, another 3. 3 times 3 is 9. And then I'm supposed to get x squared. I already have 1x, I need another one. So negative 3x times negative 3x, sorry, negative 3x times 3x is negative 9x squared. And then lastly, what do I need here? What do I need to write here? That plus is that plus. What goes here so that when I multiply that number by 3x, I get 3x. That should be a 1. And we're done. So the GCF is a 3x, and we factor it out. Alright, and you can do that, factor out the GCF, even if you had more variables. The first two examples, A and B, only had one variable, namely x, but if you have more variables, it's really the same idea. You can do it as well. So in this one, next one, C, we have two variables. So we do exactly the same process, even if we had 3, 4, 5, 7 variables, whatever. We just do the same thing for each of the variables, not just x. Then you do it first for x, and then you do it again for y, and that's it. I mean, it really works out the same way. Okay, starting with the coefficients 1, 3, and 5. 1, 3, and 5 only have in common 1. The GCF of 1, 3, and 5 is just 1. And so you can write 1 or not write anything. Okay, then for the x's, the powers are 3, 4, and 5. X cubed, x to the 4th, x to the 5th. So the smallest one of those is x cubed. That's the biggest power I can pull out from all of them at the same time. And then for the y's, the variables, the exponents are 2, 1, and 3. 2, 1, and 3. So the smallest one is 1. So y to the 1, which is 1. Okay, so that is a GCF. And now we go ahead and think, what do I need here to complete the first term? The first term is supposed to be x cubed y squared. What am I missing? Well, I'm missing a y, because I'm supposed to get back x cubed y squared. I already have x cubed and one y, so I need another y. So you have a y there. Then for the next term, you need a 3. And you're supposed to have x to the 4th. I already have x to the 3rd, so I need one more x. And then the y that is there, I already have it here, so I don't need to add in another y. And lastly, you have 5, this 5. You're supposed to have x to the 5th. I already have x to the 3rd, so I need x squared. And then I'm supposed to have y to the 3rd. I already have y, so I need y squared. Okay, and that's the end of that. Okay, if you haven't done already, I suggest that you pause the video right here and try to factor that one. I mean, factor out the GCF for that one. Okay, let's not compare notes. So the GCF for the coefficients 12, 8, and 16. So let's think. 12, 8, and 16. What is the largest factor that goes into all of them? To 12, 8, and 16. Well, 8 doesn't work because 8 does not go into 12, but 4 goes into all of them. 4 goes into 12, 4 goes into 8, 4 goes into 16, and there's nothing bigger. So it is 4 for the coefficients. Then for the variables, the exponents are 3, 2, 1. So 1 is the one that goes out. And now let's think what we need to put in here to get back 12x cubed. Okay, I have a 4, I need a 3, so that was going to give me 12. And then I have 1x, I need x squared, that's going to give me x cubed. Then to get that minus, then to get 8, I needed 2, 4x times 2 is 8, and then I need one more x to get x squared. And then lastly, 16x, I need 4. That gives me 16x. Okay, and that is the end. We finished factoring out the GCF. Okay, that's the first thing you should always do. Factor out the GCF, regardless of what method for factoring of the three methods that we're going to be talking about in a minute. Regardless of which of the three you use, the first step should always be factor out the GCF. Okay, so now we're going to talk about the next method for factoring. This method is used when you're trying to factor a polynomial that has 4 terms. It has to have exactly 4 terms. If it has 3, then it doesn't really work directly. So you need, or if it has 2 terms, you really need to have 4 terms. Okay, but the very first thing that you should do is factor out the GCF, if anything. Okay, so the idea consists of grouping, and you take the first 2, and you do the GCF, and then take the last 2 and do the GCF. But first, you do the GCF of the whole thing to begin with. So think of 3, 2, 12, 8. Do those have anything in common? No, 3 and 2 don't have anything in common. Okay, so for the coefficients, there's nothing in common. And the variables, well, there's nothing either, because some of them have x. The very last one doesn't even have an x, so you cannot pull out an x from all of them. So that's it. Well, we cannot really factor out anything. All right, and then what you're going to do is you're going to, I'm just going to copy it again for my convenience. What you're going to do is you're going to take them in pairs, and then you're going to do the GCF again, but not only for the first, for these two. So the GCF of these two, well, the coefficients have nothing in common, but you can pull out an x squared. And then, if you pull out an x squared, you're supposed to have here 3x, so that if you multiply, you get 3x cubed minus 2. Right? And now, you pull out the GCF from the last 2 terms. What is in common between 12 and 8 is a 4. 4. Okay? So factor it out and then write down what you should have left. So here I need a 3x to get back 12x, and here I need a 2 to get back 8. Okay, and now you see this. If this polynomial is going to factor, then it is always going to be the case that these two things are exactly the same. If they're not exactly the same, then either you did something wrong or the polynomial is not going to factor. All right, so that's typical. That's always going to happen in the polynomial factors. All right, so now you see that is repeated, that is common. So now what you do is, because it is a common factor. So it is a common factor. What you do is you factor it out. You pull it out. So we write 3x squared, and then we factor that out. And then you think, okay, what am I left with if I factor that out, if I pull it out? So if I pull that out, what I'm left with is the x squared. And if I pull this one out, I'm left with a plus 4. So factoring out the 3x minus 2 from both of them leaves me with x squared plus 4. And that is the answer for that. That is the factorization. And that's how this method works. You take the mean pairs, you do the GCF for each pair, and then if you did everything right in the polynomial factors, this is going to be repeated, and then you pull it out, write it in the front, and then write the leftover here. That's going to be the next factor. And that's it. Okay, let's do another one. So this one has 4 terms again. First thing you should try to remember is factor out the GCF. Factor out the GCF. All right, the GCF, the coefficients are 1, 1, negative 2, negative 2. 1, 1, what does 1, 1, negative 2, negative 2 have in common? Nothing besides 1, so that's that. And then for the variables, this one doesn't even have an x, so that's it. We cannot pull out anything. Okay, then take them in pairs. So I'm going to write it again for my convenience and take them in pairs. All right, from the first two, the GCF is just x. And that's going to leave me with x to the 4 plus 1 inside. And then from these two, what is common is the negative 2. You see negative 2 from both of them. You typically do bring with you the negative. So pull out the negative 2, and what you're left with is x squared plus 1. Know that you need a plus 1. Negative 2 times plus 1 is negative 2. If I had a negative 1 here, then when I multiply that, I would get positive 2. That's not right. Okay, almost done. Oh, there's something. Uh, oh, that's a mistake. You see that I copied that wrong. That should have been 4. I see. You see what happened there? I noticed that there's something wrong. I did something wrong because I didn't end up with exactly the same thing. And what I did wrong was copy this wrong. That should have been a 4. And that should have been a 4. So, oops, that should be 4. And that should be 4. You see, it has to end up being exactly the same. Otherwise, you either made a mistake or the polynomial does not factor like that. The method doesn't work to factor. Okay, now you see that this is identical, which is what I was expecting. And now you write that out and you factor that out. Okay, so I factored it out, x to the 4 plus 1, and then write down what is left over. That's going to be your next factor, x minus 2. So this is going to be x minus 2. And that is the end of that. That is the answer. Okay, x to the 4 plus 1 times x minus Okay, now you should pause the video and attempt to factor that one. I really highly encourage you to pause the video and try to factor that one. X to the fifth minus 3x cubed minus 2x squared plus 6. Alright, now let's do it. So I'm going to copy it again for my convenience. Okay, so now I take the first two and then take the next two. Okay, so factoring out the GCF from the first two is x cubed. When you pull out an x cubed from both, you're left with x squared from the first term and then a minus 3 from the second one because I pull out the entire x cubed outside. Alright, and from these two, you see that you have a 2 in common, but you normally pull the negative with you. So I'm going to pull out a negative 2. And then what you're left with is x squared, and then to get positive 6, you need a minus 3. Negative 2 times negative 3 is positive 6, so I need a minus 3 there. And also, you see that if I had put a plus 3, they would not have been identical, so I know something is off. But as it is, it's perfect. Okay, so that's repeated. So that's a common factor. Now you pull out the common factor. So you're going to get x squared minus 3. Write it down. And then write down uh, this part that is left over. That's your next factor in the factorization. So this is going to be x cubed minus 2. And that's the final answer. So the method of grouping works for polynomials that have exactly 4 terms, as I mentioned before. But we will also want to factor trinomials, meaning polynomials that have 3 terms. And what we do then is we cannot really use the method of grouping directly. What we do is that we modify it or rewrite the trinomial in such a way that instead of having 3 terms, it has 4 terms. So what we're going to do is we're going to take one of the terms and we're going to split it into 2, and then we're going to have 4 terms. And then we can use the grouping method that we just talked about on that. All right, so here's how this method works. So sometimes people call this method the AC method, because if you have a trinomial like this, of this form, ax squared plus bx plus c, the first thing you're going to do is you're going to multiply the a and the c. So AC, you're going to multiply a times c. So that's step 1. Then, so you're going to multiply AC and write it down somewhere. Then you're going to think of 2 numbers, a pair of numbers, P and Q, such that when you multiply those 2 numbers, you get AC, the number that you wrote down, but when you add them, you get B, and B is the number in the middle, the coefficient of the X. So you're going to think of a pair of numbers that when you multiply them, you get AC, which is the number that you wrote down, and then when you add them, you get the number in the middle. All right, and then you're going to use those 2 numbers, P and Q, to split up the term in the middle, the bx term, and write it as 2 terms. And then, because you're replacing the term in the middle bx with 2 terms, now you're going to have 4 terms. And once you have 4 terms, you do what we just did, factor by grouping. And that's the idea. Okay, so let's start by doing all of these. First one says x squared plus 2x minus 15. All right, so you multiply the coefficients. 1 times negative 15, that is negative 15. So you multiply them and you write it down somewhere. 1 times negative 15 is negative 15. Then you're supposed to think of two numbers. We're going to fill them in these spaces. Two numbers that when you multiply them, you get negative 15, but when you add them, you get the number in the middle, which is 2. We have to think of two numbers. When you multiply them, you get negative 15, but when you add them, you get 2. So what are those two numbers? So I think 5 and negative 3 work. When you multiply 5 times negative 3, you get negative 15. When you add 5 and negative 3, you get positive 2. Okay, so yes, that's the combination. That's the winning combination. So now what we do is we replace the 2x with these two. So it's going to be 5x. You have to put back the x. Uh, you know, drop the x. So plus 5x minus 3x, you put plus negative 3x. So that breaks up the middle term, and then minus 15. So replace the 2 with 5 and negative 3. So 2x equals 5x negative 3x. Okay, and then once you do that, you now have 4 terms, and you can proceed as usual with the method of factoring by grouping. So you take the first two and the next two. All right, factor out the GCF from the first two terms. That's just an x. You have x plus 5. And then factor what is the GCF from the last two. They have in common a 3, and you normally pull out the negative with you, so minus 3. 3 goes into both of them. Okay, so pull out negative 3, and you're left with x plus 5. And note that you have the same thing, so that's a common factor. X plus 5 is a common factor. Factor it out and write down the leftover. That and that's going to give you your second factor. So the second factor is x minus 3. And that is the end for that. So that's how the procedure goes. Note that this 5, and you have positive 5 and negative 3, which are exactly the same numbers that we come up here. So is that a coincidence? Or does that always work out that way? Well, the answer is it always works out that way if the coefficient of the x squared is 1. If the coefficient of the x squared is 1, then these two numbers that you think of here are precisely going to give you the factorization, so you can just skip all of this and just write down the factorization. However, if the coefficient of x squared is not 1, then you cannot do that. These numbers are not gonna be the ones that appear in the factorization. You have to go through the whole process, and we will see. All right, so let's do this one. So let's factor this one. First step is multiply the leading coefficient by the constant coefficient, constant term. So 1 times 24, that is 24. And then we're going to think of two numbers. When you multiply them together, you get 24, but when you add them, you get negative 8. When you multiply them, you get 24. When you add them, you get negative 8. I mean negative 10. So what are those? Negative 6 and negative 4 work. negative 6 times negative 4 is 24. Negative 6 plus negative 4 is negative 10. Yeah, that works. Okay, then you're going to break up. I mean, you can go through this process, but remember what I told you. If the leading coefficient is just 1, you don't have to do this. You can just, these are the numbers that are going to be in the factorization. So that means factorization is, because the leading coefficient is 1, I know the answer is going to be x minus 6, x minus 4, and we're done. I don't have to go through that process if the leading coefficient is 1. If the leading coefficient is not 1, you have to do that, do the grouping. Okay, now let's do C. 3x squared plus 2x minus 8. Alright, so multiply 3 times negative 8, that is negative 24. So multiply them and write that down, negative 24. Then think of two numbers. When you multiply them, you get negative 24. When you add them, you get the number in the middle, which is 2. So we want to think of two numbers. When you multiply them, you get negative 24. When you add them, you get 2. So I think this is going to be 6 and negative 4. Yeah, 6 times negative 4 is negative 24. 6 plus negative 4 is positive 2. Okay. Now, because the leading coefficient is not 1, I cannot just write down the factorization using these numbers. That's going to be wrong. It's not going to work out. So I have to do this process right here. I have to go through that. There's no way of doing this systematically otherwise. So let's do it then. So this is going to be 3x squared. Break up the term in the middle, 2x. 2 breaks up as 6 minus 4. So this is going to be plus 6x minus 4x minus 8. And now we're going to use grouping. Take the first two, take the next two. From the first two, what is common is 3x. And here you get x plus 2. And then from the last two, what is common is a 4, but you pull out the negative with you because it's negatives. So you actually pull out a negative 4. So minus 4. And then this is x plus 2. And note that this is repeated, which we expected that. That means it's a common factor. You pull out the common factor, which is x plus 2, and write down what was left once you pull out the x plus 2. Once you pull out the x plus 2, pull it out, factor it out. What is left over is 3x from there, and once you pull that out is a minus 4 from the other one. Okay, and that is the answer for that one. Okay, we're gonna do 3 more, but I think we've done enough examples that you might want to attempt some of these before I do them. So you should pause the video and try all 3 of these. Okay, try, or at least 2 of them. Maybe try D and E or D and F. Okay, now let's do them. So, first thing, multiply leading coefficient 1 times 9, and write it down, that's 9. And then think of two numbers, when you multiply them together, you get 9. When you add them, you get the number in the middle, which is 6. So what two numbers you get when you multiply them? You get 9. When you add them, you get 6. Well, that would be 3 and 3. And because the leading coefficient is 1, these are the numbers that are going to be in the factorization. So I don't have to go through the whole process. You could, you're just going to give the same thing, but that is it. Plus 3, plus 3. It's over. So it is easiest when the leading coefficient is 1. Those are the easy ones. Okay, the ones that don't have a 1 as a leading coefficient are the ones that require a little bit more work. Okay, now let's do this one. 4 times negative 6 is negative 24. Write that down. Think of two numbers. When you multiply them, you get negative 24. When you add them, you get 10. When you multiply them, you get negative 24. When you add them, you get 10. What could that be? I think 12 and negative 2. Let's think about that. 12 times negative 2 is negative 24. 12 plus negative 2 is positive 10. Yeah, that works. All right, because the leading coefficient is not 1, I have to go through the whole process. I cannot just write these in the factorization and say that that's correct. Now, look what happened here before I continue. Normally, the very first thing that you should always do is to factor out the GCF. In all of these ones, the GCF is 1. If you go back and look, all of the GCF is 1. So really, that means you don't end up pulling out anything. But in this one that I'm doing right now, the GCF is not 1. The GCF is actually 2 because 2 goes into all of these numbers. 2 is a common factor of 4, 10, and negative 6. And I forgot to do it at the beginning. And that's all right. I mean, it's not really required that you start with a GCF being the first step. If you forget, it's not the end of the world. However, if you do forget, you're going to have to do it at the end. If you don't do it at the beginning, you have to do it at the end. So let me say that again. If you don't do it at the beginning, you have to do it at the end. So you will see what is going to happen. Okay. And it makes it easier that if I had remembered to pull out the 2 from here, the numbers would have been even smaller, which is even easier to do. Okay, so let's do this. So now we're going to break up the term in the middle, which is 10 with 12 and negative 2, and then you have minus 6. And then you take the first 2 and then the last 2. All right, the first 2 have in common 4x, and then this is going to be x plus 3. And then the next 2, you pull out a negative 2 that is common to both, and you have x plus 3. All right, and now x plus 3 is repeated, is a common factor. So factor it out, you have x plus 3, and then you would have the leftovers are 4x minus 2. So that will be the last term. And that is a factorization, but is not factored, is not simplified or factored as much as possible. Because you see now 4 and 2 have a 2 that is common. I could pull out a 2 from both of them, and we should. So pulling out a 2 from there, and I'm going to put it all the way to the front. Factoring out a 2 from here, you would have left 2x, factoring out a 2 from the 4. So 2x and factoring out a 2 from the 2, you get a negative 1. And you see, if I had done that at the beginning, I wouldn't have had to do it at the end. You should always double check for things like that. Can you keep factoring? Is there anything in common? Can you keep going? And if you can, then you should. All right, so again, reminder, GCF first, and it's gonna make your life easier. Okay, the very last one. The GCF of that one is 1 because 5 and 17 and 6 don't have anything in common. So the GCF is 1. Good. Then multiply 5 times 6 and you're going to get 30. And then now we think of two numbers. When you multiply them, you get 30. But when you add them, you get negative 17. And I think this is an easy one, 15 and 2, but you have to choose the signs appropriately. Negative 15 and negative 2. Negative 15 times negative 2 is positive 30. When you add them, you get negative 17. Okay, that's good. So now we use this. So let me change the color. Get mixed with the one on top. Okay. Uh, so we're gonna break up the 17 in the middle with these two numbers. So minus 15x minus 2x plus 6. Then factor out the GCF from the first two and then the last two. So group them. From the first two, you have 5x is common. So you have x minus 3. And then from the last two, you have a 2 that is common. Pull out the minus with you. So minus 2. X, and that should be a minus 3 because 2 minuses is what's going to give you back a positive 6. And also because, I would have noticed that there's something wrong if I had written plus. They have to be the same. So now, that's the common factor. Factor it out. And so pull it out when you're left is 5x. And pull it out when you're left here is minus 2. Okay, that's the end. Okay, now that takes care of how to factor trinomials. The very last the very last method is how to factor difference of squares. And this is a formula that we already, that is used when rationalizing. If you remember, we use it backwards, but now we're gonna use this formula for factoring. So the formula says that if you want to factor something that is a difference of two squares, then you can factor it using this formula. It's going to be the product of these two factors. The first one is going to be x minus y, which is basically what you would get if you drop the squares. If you drop those twos, what do you get? You get x minus y. So x minus y is the first term. And then the second term is same thing, but with the sign in the middle changed. Some people write x plus y first and then x minus y. That does not matter. That's immaterial. All right. So x minus y, x plus y. But you have to recognize that you have a difference of squares. You have two terms and they're both square of something. All right, so here's the first one. First, remember to try to factor a GCF. GCF is 1. 1 and 9 have nothing in common, just 1. So then this is the same as x squared minus 3 squared. I recognize the 9 as the square of something, namely the square of 3. So now this formula tells me that the first factor is x minus 3, which is what I would get if I drop the 2's. And then the second factor is the same, but with a plus in the middle. And that's it. All right. So that is simple. I mean, this formula is actually pretty simple. Next one, GCF, if anything. GCF 101 have nothing common besides 1, so their GCF is just 1, 2. And then you have to recognize this as that 100 is the square of 10. So this is going to be, this is the same thing as 10 squared minus y squared. And then, using the formula, the first term is what you would get if you drop the 2's, so 10 minus y. And then the next term is exactly the same with the sign in the middle changed. Okay, that's that. So it is actually pretty simple. Let's do another one. First, you have to recognize this one being a difference of squares is a difference of which two squares? Well, the 25 is 5 squared, but what about the other one? The other one is also a square, and namely, it is the square of 3x. If you square 3x, you get 9x squared. So the whole thing, 3x. You have to square the 3 and you have to square the x to get 9x squared. So this then is the difference of squares, namely 3x squared minus 5 squared. 5 squared is 25. So then I wrote it as a difference of squares, and now according to the formula, the first term is what you would get when you drop the 2's. So this is 3x minus 5. And the second term is exactly the same thing with the sign in the middle changed. So 3x plus 5. All right. Now you should pause the video and try that one. And think about E as well. That's when it's interesting. Think about E. Okay, let's do them. The first one is the square of x, and the next one is also the square of something, namely the square of 3y. If you square 3y, you get 9y squared. Okay, so then according to the difference of squares formula, the first term is what you would get when you drop the square, so x minus 3y. That's what I would get if I drop the 2's. And then the next term is, the next factor is the same thing, but the sign in the middle changed. That's that. All right, and the last one, it doesn't look like a difference of squares, but it actually is. If you think about it, the first term is the square of something. It says x to the fourth, but it is the square of something. It is the square of what? What do you need to square to get x to the fourth? A square. So x squared squared gives you x to the fourth. Okay, so that was the trick. And you can do that with any exponent that is even. It's the same. It would be the same thing. So if it was like x to the 10, so if it was like x to the 10 minus 16, then this would be like x to the 5th squared minus 4 squared. All right, so as long as this exponent is even, you can do that. All right, so this one is x squared squared minus 4 squared. The first term is going to be x squared minus 4, which is what you would get if you drop the 2's. And then the next term is the same, but with a plus. And now you might be tempted to say that that's over, but that's not over because this one is a difference of squares again. So that means we're supposed to continue. We're supposed to keep going. And, you, and it is your job to recognize that you can keep going. Okay, so that means this is what difference is squared. X squared minus 2 squared. So that means this is going to be x minus 2, x plus 2. And then sums of squares you can never factor. That you cannot factor that. That is done. So that would be the